All right, hi everybody, David Cross here, and welcome back to part 2 of the Cloud Automation Quick Start. And in this video, I'm going to walk through the sample workflows that are provided with the automation appliance that interface to IPControl and also the Amazon Web Services, and specifically the VPCs, the subnets that are allocated in those VPCs, and the IP address instances that are also assigned in those environments. And so what we provide effectively are 4 different nodes or 4 different workflows, each one allowing you to do different functions programmatically, such as creating subnets, deleting, synchronizing subnets between AWS and IPControl, and synchronizing the IP address instances between those two environments. So kind of to begin with, there are a number of prerequisites that we need to have set up that I'm going to kind of pull up a PowerPoint here to go over real quick. And specifically what we're looking to do here is we need to identify some block types that we're going to use that are going to be associated between the Amazon Web Service and IPControl that will represent the network, and these will be your root networks in that environment. And then also a block that we can represent subnets and something consistently that we can use for all of the subnets. So in my case, I created a block type of AWS, which is under Tools block type. And that AWS is a parent and created a child of VPC, which is where I'm going to create my subnets. The second part is you need to have some type of container hierarchy that allows you to somewhat map your AWS hierarchy to IPControl. And AWS organizes data through VPCs and availability zones, or zones that you're going to store the data, or servers. So the way that we've recommended, or that we've done it here, and especially because the way the nodes in the automation appliance are designed, I created a container specifically for AWS. It only allows for AWS block types at that container of a root, and then allows for the pass-through container of the VPC to pass through to the different availability areas. And the availability area, US East 2A in this case, is where we'll store the subnets and where we'll have the VPC assigned type. And because we have to send that type in as a payload when we're creating a block and or specifying our script, we want to make sure this is defined. And then the fourth part of this step is actually creating that root block. Now, you need to be careful of this in case you're using whatever space Amazon provides in your existing database, and in the case that it's overlapping. So if you do have overlap, you'll need to specify overlap support within the block when you create it and or afterwards. And if you have a overlapped block in the in-control container, it will have to be moved so that it's a peer of AWS and will not cause an overlap conflict, which if there was a 172.31 and in-control in AWS, those would be conflicting. And the reason for this is when we go to log in, we're going to set up specifically what the container is that we want the nodes to work within, and it's going to specify, in this case, in-control AWS, and then the nodes themselves are going to append VPC and the availability zone to the containers. So we'll see that as we walk through it. And the second part of the requirements are the AWS requirements. Clearly, you need to have a user. That user needs to have permission set up to allow you to do certain things with your VPCs. You'll need to check with your admins for that. But specifically, you need to have the ability to work within the VPCs, and you must have an access key ID. And when you create that key ID, it creates a secret key. You'll need both, and you don't want to share those because you'll need to have those in order to authenticate to Amazon through our login node to perform those APIs. You'll also need to have a firewall rule set up to allow the IP of the CAA automation appliance to talk to the internet in AWS. And you'll need to have an IPControl login with a minimum to allow read, write, delete permissions within the AWS hierarchy of containers to allow you to input, export subnets. And the way that we're using the AWS node integration is very similar to the command line interface that AWS provides, in that you can do a description or describe instances, describe subnets, describe VPCs, and that'll give you basically the information back. And just to note, the instances are the IP addresses that you might spin up a VM in the cloud. Those are the IPs stored in those VMs. That's what's being synced back to the subnets. So let's get out of there and let's just real quickly walk through IPControl to show you where those settings are. So under Tools, your block types, you'll go Add Block Type. You'll specify AWS as the parent or as the block type, no parent. Do Submit, then do Add Block Type. You're going to specify then VPC or whatever your subnet level block type should be, and it should parent to your AWS. Then go over to your Management Container Maintenance. You'll want to click on whatever container you want to mount the AWS to, and I did mine on InControl. You can do the same there. So click InControl and do Add Child Container, and when you do, you're going to specify AWS as the name. The valid block type should only have the AWS root block type supported. That also should be set up as allow root block creation, so the only type. And there should be no allocation from parent. We're not going to recurse up the tree to look for any other space. Everything should be right here in AWS. Go ahead and submit that. Then refresh the hierarchy, click on AWS or the container you created, and do Add Child Container. And you're going to specify this time the VPC name, which is the ID specified in your VPC instance as you're looking at that. The valid block types here are none. We're not going to allow any. We're not going to allow any root blocks, but we're going to pass through the allow parent for AWS. And this will give us the ability to just pass the request from the lower container upward to AWS. So submit that when you're done, refresh the hierarchy, click on the VPC container, do Add Child, and this will be the last one. Specify this as your area availability zone that should be specified for your subnets. So if you look at the different subnets, they should have that zone available, and this is what we would use here. Okay. So that's the container structure, and in here you want to have valid block type as a VPC type only, no root, and allow should be from AWS. So it'll create the subnet local, but it'll look up to the parent container for the block and bring it down and assign it. And that's pretty much all we need to do for the containers and block types. And lastly, you'll need to go in and set up your root block. So in AWS container, you should see the root block tab or button. Enter your IP address of the address and then type and do size. In this case, mine's a 16. I'm going to keep the same name, and I'm not going to do really much anything else for this. And then just go ahead and click Save. But you might want to label under the cloud type Amazon or something like that. We don't have an ID yet, so it doesn't really matter there. So effectively, when you have your 172.16 created, and I've already synced this, I'm going to delete it. We should be ready then to begin provisioning or working with the sample nodes. And just keep in mind again that anytime we start to synchronize subnets, the login node is going to represent this as the container, InControl AWS, and it's going to append this VPC and availability zone to the subnets when it imports them for the container. Okay. So which brings us into Node-RED, and we want to go ahead and log in. The login node, when you first see this, and the intent initially was that each of these nodes, let me get rid of these logins here so you can see this. Okay, by default, none of these have a login node serialized in with the containers. They're basically saying that you want to have a login that's going to call this login node, passing the username and credentials and your Amazon key ID and the secret ID to this login function. And it's going to give you a token that you're then going to use later on in the process to represent that you're authenticated. And in a case like that, you're basically telling it to use the authentication bearer or authorization bearer token. Now, what that looks like by default when you first log into this is a curl command that allows you to specify your username, password, and that you're going to upload this, and then it's going to log you in using those credentials. Now, if you're using AWS, you'll also need to pass those in, but we're going to get to that in a second. So in the curl command, I don't like to specify usernames or passwords on the command line. I try not to. So what I have is I have a .password file that I keep my password for my user in, and I cat it out and create a variable that I then pass into the password. So I don't have to use it. I just put the user on the command line. Then the curl command is set up to ignore the certificate -K, to be silent, no verbose output of the percentage of done. And I want this to have a post, which is -X post. The header is going to represent that this is an application JSON as a content type that we're uploading, and that we accept application JSON. And then we effectively create a data structure, and in it we have the username, variable, and password. So what I'm going to do on this script to demonstrate this login is I can run this under curl on the command line and just pass my username. This will then cat this password file with my password, create a variable, pass that into the string, and then it's going to go out and give me the access token. And this access token then is used through other processes to build your API. So this is what's used to help you authenticate when you move forward. And the requirement with that is then that every time you do a curl command, and let's see if I have an example here. So we could do curl -K -S -X. We're going to do a get this time. And we'll go ahead and do content type. Actually, we're going to do accept application JSON. And the way we use that token then is you use authorization, bearer, and we want to paste that string effectively. So I want this to be all the way from here, and I want it to include that last part of the string there. And then my URL is going to be, we'll do my CAA, and this time we're going to use 8443, which is the regular Tomcat ports. And we're going to use the Increst API v1 gets get admin name equals, and we'll just do my admin here. Okay, and for those of you watching and paying attention, you'll notice that I didn't set the address right. So you need to make sure your details are set right. So once I have the right structure, that key then, the way it's expected is that you pass it as a header into this authorization bearer header, and then it's going to then call your APIs, which is the endpoint here, and you're either going to pass it a data structure if it's a post, or just a get and a parameter on the get line, which I did here, and that's going to pull back your JSON that you can then use throughout the process. So now, to familiarize yourself with this, just as a key hint before we go into anything else, you should be aware of the Swagger interface that allows you to log in using your credentials of IPControl and access the various APIs and the workspaces so you can see the headers, see the curl syntax commands, how it's used, and familiarize yourself with this JSON and other functions. Also gives you the header requests and the schemas and so forth. So familiarize yourself with this. It's HTTPS, your IP address, :8443, and then /inc-rest/api/docs/index.html. And at the top, you can authorize using the OAuth using your IPControl login credentials. And if you need to have the ability for many of these APIs, the right IPC permissions. So familiarize yourself with that because you'll use that when you're parsing through this data. So we don't want to do this with the IPControl login because that means that I have to go in and create headers each time and structure it. I've done that before where I create the login, pass it all the parameters I need, then using the script, create the token. But we're going to do something different this way. And I want to do it so that I don't have to pass a username and a password. So the first thing is I want to create a file that has a base64 pair, which is something we're going to use for your authentication basic. So effectively on Linux or some other service, you can type in the echo, your username, and I might do mine here, and then pipe it out to base64. This is the digest string, which is made up of this combination. If you copy that into a .dot file, a personalized file that you can secure and protect, like I have with mine, I'm going to use a cat command that creates this that will effectively call the home directory and then hpwd, which you'll see in my coming scripts. So I don't want to use any user logins at all. I want my script to have this and already hashed out so I can just call that into it. You also may have the point where you want to have that password file, so do the same there. Okay. So with the login, since we're going to use the hash and we're going to be able to create that there, the second thing that you're going to need is you're going to need the secret ID or the key ID and the secret ID, and any of the scripts that we use, such as synchronizing, let's just pull this up here, sync subnets. In all of the scripts, I have another file that I have the key ID and the access key ID stored in that are separated by a colon. So it's the key ID colon secret ID, and then I'm going to cat that out using the backticks to create a variable that I'm going to use for those two parameters in my JSON and the payload that's being sent into any of these node workflows that we're going to work with. So the way that all of my headers then will read are, I'm going to cat out my header password, which is my username password digest. I'm then going to get my key ID and secret key, and I'm going to use those as variables. And a lot of these, I'm going to create a variable then, so that's going to store whatever output using my curl command. And the key here is I'm going to create a header, dash dash header, with the authorization basic using that header. And then I'm going to open it up with a data structure, and everything in between the single quote, curly bracket, single quote, closing curly bracket is our JSON payload. So in there, we're going to pass in that secret, the key, the region, the VPC, and then we're going to tell it that we want to add any subnets or delete any subnets when synchronizing. So it'll handle that synchronization for us. And then the endpoint that we're calling is our node red, and that is the IP address :1880. It's all under HTTPS, and it's /workflow/sync subnets. Okay, so this is the script we're going to work with. And because we're not going to use this login function, I'm going to go in and put a login node and inline chain it to all of these commands so that I can use the authentication basic each time, and it'll use this login node. So the key here is drag the node to the subnet or between the line of the subnet, with the endpoint and the next node, and you'll see the line is then dotted. If you drop that, it'll then connect the node between the two nodes around it. Double click, very important here, select the 127.8443 in the properties and make sure that you're mounting to the container, root container, and that you're using tokens and ink rest. Go ahead and update it if you're not. And very importantly, make sure that the property output is anything other than payload. If it's payload, it's going to overwrite the node input and it'll invalidate our workflow. And when you're done, deploy the node, and you should now be able to call this function. So I'm going to do this with each of these so we don't have to do it each time. And we're going to make sure we select each one. All right. And then here, I'm going to use cred for each of these because that's consistent. And again, I don't have to double check this, but I like to make sure. I've had a few mistakes here and there. And then the last one is a sync IP. So we've got these all connected, and now we should be able to start using our scripts. And that looks good. So go ahead and deploy your changes. And the very first function we want to run when we have our containers and blocks block types is we want to basically synchronize the subnets. And what this is going to do for us, I won't go through all these nodes because you can see what they are, but we're going to send in our login information, which logs into IPControl and Amazon. It's then going to save the parameters we need, which prepends what our container is. So this is where it takes the VPC and the availability zone and appends it to the IPControl AWS root container. That makes sense. It's also going to create the other variables that we're going to use later in the process, and it's going to do that outside of the payload. So anytime you're working with node and your node is in the middle, you create a process, you should store basically the original information elsewhere, manipulate the payload, and then be able to pass back in the details as necessary without destroying the initial input, which is the key. So from here, we have a couple of nodes that go out and describe all of the subnets using the AWS describe subnets. It's then going to store those into a variable, and that variable then is going to be read by the sync subnets. In the INC, it's going to use sync as well, and it's going to synchronize the IP control export of the VPC data for this container into a list, and then it's going to tell us what the differences are. So the sync subnets creates an add, a delete, and a commons. There should actually be commons in the documentation, showing us where there's differences or similarities. Then it's going to go through a number of change nodes that are going to help them construct basically more field information based on the synchronization data. So you'll see here now that the sync adds are moved back into the payload and the payload adds and reference from that point forward. A switch node that's going to look for that. Is it true for adds or is it going to be a delete? And it's actually looking at the variables. Does it exist? Meaning that there's a structure for these adds to exist and that the count is greater than 0. And this is using a structure called JSON-ATA to do some sequence. It's not JavaScript, close to it, but allows you to work with the message payloads in somewhat of a syntax, a scripting syntax. And then finally, when it gets through with the sync and splitting the data, the split node takes each of these IP addresses that are coming in, checks their information, sets the parameters for the block. So this is going in and setting up all of the different block information. And then it's going to pass it to the import address child block. So this will create a new child block in IPControl and or delete a child block in IPControl as well if it's told to delete. So that's what we want to run first because we don't have anything in there because I deleted that subnet. So if I go out to my structure again and I just run the sync subnets through my script, I should get really nothing back the way my script is working. But if I refresh this information, I should then have the base subnet that I'm working in, and it's my 172.31.0.0. So that's my subnet, and that's the detail that's brought back in. And if I had any debug, I should also see some of that detail. So if I want to look at the VPCs and that detail, I can, and we can see the information. So that's the sync. And once I have the sync, I can do other functions in here, such as create subnets through an API, have that API created in IPControl first, have it determine the next available subnet, and then upload it into Amazon to create the subnet there. So like we're doing again, we log in, we set up our container and subnet details, add the child block, which we're going to tell it effectively in our script to do the next available, adds then the subnet, and when it does that, it's also going to capture the cloud object ID and sets it to the subnet ID, which is calculated by Amazon. So Amazon does that for us, returns it, and we're going to collect it and then update, which is the modify child block, to set that parameter. And then we return the response back to the client so that you have a response and or function. So what we would have then if we wanted to create this, and I'll just take a look at this structure. I have a script for add subnet AWS. It is using the same variable settings in the top to grab the information, setting a variable with the curl syntax, adding our header authorization basic for our login, access key, super key, the region and availability zone of VPC, the IPC net add and delete again, telling it true. And this time we're going to tell it the size of the subnet we want to create, 24 in this case, the address we want to use the next available, and this is an IPControl feature, v4 for the address, and the block type is VPC, which we created here so that if we were to look at block types, it would only be VPC in the interface. Okay, so now if I do add subnet, it should give us the next available subnet. And if I go back in and refresh my list, I'll then see 31.1.0. And I can do this a couple times. We'll just create a couple here, each time creating a new subnet and the next available, and synchronizing that data in the cloud and IPControl. So now if I go out and refresh my list in Amazon, I should also then have those same addresses. The sync IP addresses, once we have the imports or the subnets imported, we can also synchronize instances or IP addresses. Again, your login node, again, make sure that the payload is set to something else than payload. It goes out and gets the subnets. It then exports all of the instances using the describe instances command. It exports all of the IP addresses for the subnet using the export device. And then it compares those two again through the sync IPs. And this again is the add, delete, or comments functionality. It then uses the various nodes to change and switch between the different values. And then it splits each one of the additional IPs to add each IP individually. So it basically does an array. Each array is an element, and each line is sent individually through the add. And all the results are joined at the end once they're complete and passed back to the client. And that's effectively how that works. And so when you do the sync IPs, it's going to pull back any instances or VMs that are deployed. Now, in my case, I only have one, so it only pulled back the one IP address, and that is this 131.0.112. Now, a couple of key notes to note about any of these subnets and things is that you do have the ability to use tags. And so tags are Amazon's way of user-definable fields. And those details do get pulled back in with the various describe functions. So you can set up user-defined fields in Amazon and then have that information read from the various export functions to do something else to, say to determine the next route or functionality in the system. All right, and so the deletes, basically the same thing. We're logging in, we're passing the payload of data, telling it what to delete. It gets the block from IPControl, deletes it from AWS, and then deletes it from IPControl. All right, so working in that synchronization level. The node and switch blocks in there as well. So with the delete block, I'm doing something a little bit different in my script, that I'm basically adding the field address to the additional AWS fields to tell it what subnet to delete, so that I can pass that as an argument, the first argument actually, and then it's going to consume the workflow delete subnet API. So here, if I do delete subnet, and first let's look and see what we have. It should be, I guess, 3 through 0. Yep. So we can do delete subnets, and then I'm just going to tell it 170.31 1.0. Shouldn't get nothing back. We'll do 2.0, and then we'll do 3.0. And if we look back in IPControl, those subnets are deleted. If we look back in Amazon and refresh, those subnets are deleted. And again, we can go back through this process. So there you go. And that's a really high-level overview of Amazon. Quick sample use. This is just right out of the box. As you see, it took us less than 20 minutes or so to set up. But allows you to interact with Amazon in that way so that you can programmatically do these things. Now, some of the things that we're going to get in some of these videos is the callout manager and how you can tie the child block add delete functionality of the web interface into the scripts to do this automatically. And what we can do with that basically is use the enable callout for the block callout. That sends all of the attributes about the transaction where we can do something external in a script. And in that external script, I can then call these functions, passing the parameters necessary or setting that up ahead of time so that it can automate the add, delete, or modify each time I do this function in the web interface. So that's down the road, a little bit further down. So we'll have to get into a little bit more scripting and functions, but something that we're going to do at that point. So there you go. And thank you for taking your time for part 2. And I'll be back in the future here, soon future, to do part 3. And I think at that point, we'll go through some custom nodes where we can start designing our own, adding IP addresses and perhaps having it go out and export whatever subnets are available based on a lookup ID of, say, a VLAN or a name or something like that. And in my case, I have a couple workflows that we're going to use the VLAN to go out and calculate the utilization and grab the next available and so forth. So hope you hang around with me when I go through these, and look forward to that here in the near future. Thanks, take care, and have a great day. See you soon.